Okay, trig. Draw the angle -7 pi over 8 in standard position. So here's what I'm thinking in my head. 8 pi over 8 is 1 pi, right? So 7/8 is just short of a full pi. And what do we do in a negative angle? Then we go this way, not quite a full pi. That's what my thought process was. State a positive coterminal angle. So coterminal means we could make a move of any 2 pi amount. So that's a full circle is 2 pi. And in this language, since the bottom is 8, what will I do to the top? 16 over 8. So this is what I'm going to do. I'm going to take what I have and add a full circle to it. But I'm changing the fraction to match with the 8, which is 9 pi over 8. Does that make sense? That it would land in the same spot? Because if I was to think about drawing it, it would look like that, which is in the same spot. Okay? Drawing angles, I do need to see your swivel to show me what direction you've been moving, okay? What is the arc length? So this is the formula on your formula sheet. When you use this formula, it doesn't tell you, but what do you know about the angle when you do arc length? It has to be, oh good, everybody remembered. Radians. Has to be in radians. So the angle times the radius. How do I go from degrees and change it to radians? Does anybody remember what to do? Pi over 180. Okay, I'm actually going to do this all at once in my calculator. I'm going to times pi, divide by 180. So I just typed all at once. How many decimals am I expecting you to go to? 3. You can go to 4 if you want. That's even better. So that is the arc distance. Hey, I was using this the other day on my pool. I wanted to see the arc between my posts. There we go. Don't you use it in real life. If the angle terminates in quadrant 2, and it gave me the cosecant, which is the what letters? And I'm so nice, I'm going to give you that. Cosecant is an R over a Y. So I'm nice enough that I'll give you that on your exam. Can you put those two numbers on that triangle somewhere then? So this would be the 3, and this would be a 2. What do you know about positives and negatives? Well, no matter what, r is positive. R is always positive. This y is located up, and this x is located left. So I would know that about my positives and negatives. And this is a Pythagorean theorem. Would I add or subtract to get it? So 3 squared, subtract 2 squared. 9 minus 4 is 5. Does that square root nicely? Nope. So I leave it. When I do a tan ratio, then I'm looking for a y over an x. That's what I would like you to write. So tan theta equals the y over the x. And this is fine. You would probably see me just writing it like a negative fraction instead of 2 over negative root 5. But okay, exact values. So when you see the word exact, do you think I'm going to go to my calculator? No. Where should I go as soon as I see the word exact? I'm sorry, you don't get the answer key on your exam. We go to our unit circle. Okay. So, what does sign ask me to find? Which letter? Y over R. What is R on the unit circle? 1. So is it okay if I avoid it? Because I don't care to divide by 1. So I'm just going to look for the Y. Secant. Oh, this is the flip. What is it the flip of? Cos. And cos is which letter? X. So I'm going to get the X, and I'm going to flip it. And the tangent is y over x. And you don't get anything fun with that. You just have to do the division. Okay. On my circle, where would I put my finger if I could rotate 11 pi over 3? How do you figure that out? And by the way, it's going to be more than a full circle. So what is this? 3 over 3. What is that? 6 over 3. What is the next half? 9 over 3. And then if I got here again, it would be 12. So don't do that. So what am I looking at? I'm looking at this position. That's where I'm looking. So can you put your finger on that position? And what is the y value is what I'm going to write. So negative root 3 over 2. Okay, 4 pi over 3. There, we can just go to it. 4 pi over 3. We already said we're going to take the x value and then flip it upside down. So 2 over negative 1. Okay, negative 5 pi over 6. Where are you looking when you are going negative 5 pi over 6? Did you pick this position? Right, we went backwards. So I'm going to look here. I'm going to take that divided by that. Okay, my next step, I had a division, so I changed the divide to a times flip. Are we okay with that? Dividing fractions, I'm flip with a multiply. So I just rewrote this piece. Okay, can anybody tell me right now, is my answer positive or negative? What is it, positive or negative? How many negatives do you see? 4. 4 negatives make a positive. So my answer is positive. And we're going to start canceling. What do you want to do here? A 2 and a 2. A 2 on top, 2 on bottom. A root 3 on the bottom, a root 3 on the top. What's our final answer? Positive 1, yep. Positive 1. That's final. Okay, solve for the angle. So, not thinking with angles, just what's the algebra? Do you isolate or do you try to factor? What do you want to do? Factor. What if something didn't factor? Quadratic equation. Do we have something that works though? Do we have multiplies to 4? 4 times 1 minus minus. So that should work. Factoring works. So tan of the angle equals 4. Tan of the angle equals 1. No, that's like 1 out of 5 points, so don't stop there. What I solved for was the trig value. This is only the trig value. What am I trying to get? I'm trying to get the angle. So here's my first step. Astica, where would I be if the tangent was positive 4? 1 and 3. Okay. I'm going to go to my calculator now. So now I have to decide the mode I want to be in. So if it tells me all real angles, the angle could be anything real, what mode should I be in? Radians. Radian mode. Okay, I'm going to tan inverse 4, and I get 1.3258. So I'm going to do 1.326. Okay, now, do you understand that is exactly a pi away from that. Do you see it? Diagonally, that's exactly a pi away. So I can write my answer is this number plus every time I go a half circle, I'm at another answer. This is every half circle. Pi is every half circle. Some of you might have written two separate answers. And then this number, if I added pi, would be 4.46. So you could have done that. That's fine. You could have wrote this and every circle of it, this and every circle of it, or the simplified version is this and every half circle. It only works with tan, because tan is diagonally across. But bless you. Okay, tan of 1. Which quadrants are you in? 1. Positive 1 for tan, so then you're still in quadrants 1 and 3, right? Still in the same quadrants. I'm going to tell you you don't have to use your calculator for this. Some of you might have already, but I don't want you to. Okay, here's my thinking. Tan is a y over an x, right? And I know that it equals 1. Where on the unit circle do you have the same xy that divides to 1? Where would you have the same x and y coordinate? Right here. Pi over 4. And in that spot, so some of you might have done this. Technically, it's not wrong, and you would have got that 0.785. Yeah, because pi over 4 is 0.785. That's why. But I'm saying on a provincial exam, if you ever ran into that, it would be on a section where your calculator has probably been taken away already. But you don't have that problem. But if I ever say a word of exact value, though, exact value stuff, like you can't answer me decimal, then you would have to write. No, on this question, you would be able to do a decimal. It's fine. So I could answer with just the pi revolution of it, or I could do them as two separate. Okay, solve this equation. We have a problem. I have sines, coses. I don't like that. What should we do? Replace the sine squared. Okay, so I'm going to go to my formula sheet. Sine squared could get replaced with 1 minus cos squared. Okay, is this okay? Sine squared could get replaced with 1 minus cos squared. Because I can see this is going to be better because I'm going to have cos squareds and coses. So everything's in the cos language, not two different languages. Okay, I have to do this. That would be my next step. I would say that I've seen a lot of math errors on that step because the forgetting to distribute both of them. with a 2? Now I'm going to put those numbers together. And now I've seen a lot of errors on that step because this negative situation. Okay, what would you do if you ever saw something that looked like this? Move it, because I hate the squared's negative. But when you move it, are you understanding everything changes? You're timesing by -1. That's the same idea. You can say I'm timesing by -1 or moving it. Okay, now factors or quadratic formula. So 2 cos theta and 1 cos theta. Where are you going to put the 3 and the 1 to make that match? You have to be careful. This one could kind of go almost one way, but not. -6 and +1. -6, +1. That is the only thing that works. Some of you would have, if you mixed those up, it would have been 2 and 3, but then to make them both negative doesn't make the -3 anymore, right? Okay, cos theta equals -1/2. Cos theta equals 3. Okay, you've done a lot of work already, but you only have received 2 out of 5 points on this question, by the way.
Hey, just still technically almost 50%.
So, I still have to figure out the other half of this problem, which is what's the angle. So don't stop here. Angle, angle, angle. Okay, I'm going to do this one first because it's fast. Why is this one fast? Error, what am I gonna actually write though? No solution to this angle. Cos and sine can't go higher than 1 or -1. Remember when we graph them, the sinusoidals, they don't go above 1 or -1. Okay, cos -1/2. Which quadrants would you be in if cos was negative? You'd be on the left-hand side of things. No calculator. Because is 1/2 a number you would see on a circle? So where is there an x value of 1/2?
Why is 3 no solution?
Did you try to cos inverse it? Cos inverse 3, error. Or do x values, can the x value go to 3? No, the highest x value goes as 1. Yeah. Okay, did we find a -1/2? So I found this. So -1/2 is at 120 degrees. And the other -1/2 is at 240 degrees. But there's some problem here. What does this tell you? What does the angle have to be?
180.
Between 180 and 360, so what?
120 is wrong.
120 is not going to work. So, out of all that, there's one answer.
That's worth 5 points.
Yeah. You could have had up to 4 answers, and then we only had 1. What's that?
Mark,
Can you explain that one more time?
What am I doing?
why can't there be new answers? I just thinking random.
This says that the answer that I give for the angle, I'm recording it, Trevor. I'll send it. The angle has to be bigger or equal to 180 and smaller or less than 360. So 120 degrees, is that in that interval? No. Is that all you wanted me to explain? Okay. Exact value of 13 pi over 12, the sine of it. When you look at the unit circle, do you see out of 12? Do you see any bottoms out of 12? No. So which outcome is this? What is 180 divided by 12? 15 degrees. So where did we do this one?
Wait, why are we doing 180?
So these are the special angles. The 15, what's the other special angle? 75. These angles are the in-betweeny angles. This is the outcome. Okay, ready?
Can we get that on the formula sheet?
No. We can make this though in radians. Ready?
Wait,
This is pi over 12.
this won't be on.
This is not on your formula sheet. Pi over 12. What's the top? What's a half of a pi? 6 over 12. So therefore this is what? 5 pi over 12. And this is 7 pi over 12. What in your head do you think of with a full pi? 12 over 12. So this is 11 over 12. 13 over 12. What number would be directly at the bottom? This was 6, this was 12, this is 18. So this is 17 pi over 12, 19 pi over 12. And what's the 2 pi number? 24. So then this is 23. So we landed 13 pi over 12. That's where we landed. So my question for you is, what did it end up? 15 or 75 degrees away? What's the in between the x-axis reference amount? We're 15 degrees away, right? Okay, what combo, when I think of a combo with 45 and 30, can I use? 45 subtract 30. Now, I grab my formula sheet and I have a formula. So, subtracting angles, and then I write this formula out. So sine 45 cos 30 minus cos 45 sine 30. So I found the formula sheet. Okay, what I do is I always do the 45s because here's why. They're all just root 2's over 2's. So I don't care what I'm looking at. Every time I see a 45, root 2 over 2. Cos 30 is the x value. So root 3 over 2. Sine 30 is the y value. So 1/2. So this makes a root 6 minus a root 2 over, what's the bottom number? 4. I'm not done because I have to do my Astica thought. And what do I know about the sign value in this quadrant? Sign is negative, so I'm going to put brackets with a negative. Because the Astica quadrant, I'm in this third quadrant, and sign has got to be negative there. The other kind of question you might see is if I asked you something like the secant. So you would do the same thing, and then what would you do at the end when you're doing cosecant or secant? You just flip it, right? But do the same, flip it at the end, okay? Okay, we are given an angle A and an angle B. So the sine of A is positive, and it's in quadrant 2, so we know that. Sine is which letter over which letter? Y over R. So there's a 5 and there's a 13. Pythagorean theorem, I will subtract. And it gives me 12. And what should I put on that 12 though? Negative. So I'm just going to write this here. Sine A equals 5 over 13 cos A equals what over what? X over R. Okay, this is all just background work. I haven't even started answering the question right now. Okay, let's talk about angle B. B is in quadrant 4. So I know that. And the cos, so I'm giving the X and the R, so the 2 and the 5. Okay, now I'm going to do 5 squared subtract 2 squared, which is 21, right? So root 21, because I can't do that. And it's a y value, so it's negative there. So I'm going to write the two ratios, the sine and the cos ratio. So I'm going to go y over the r, x over the r. Do we understand where to put it if it doesn't tell me the quadrant? Like I might say, where is sine positive and tan negative or something like that? Do you understand how to figure out your Astica spot? Remember that? Okay, here's what I'm asked to find. Cos A plus B. So I need a formula, so now this is formula sheet time. Cos A plus B. So cos, cos, sine, sine, that one. Okay, so I copied that off the formula sheet. And now I'm going to put 4 brackets, and all the work is done, so I just have to fill those in. So the cos A replace with the fraction that you had. Okay, the bottom number, so 13 times 5 is on the bottom, so that's 65. This makes negative 24. I'm subtracting a negative value, so I will add. And how do you write that then? How do you write that piece? 5 root 21. There's nothing that you can do. You can't combine things like that. You just leave them times like that. That's it. That's as far as you can go. So part B says find sine of the double angle. So we're going to go to this one and find a formula. So 2 sine A cos A. So that's the double angle formula. And now I'm going to put some brackets in those two places and make those replacements. Okay, so if you really want, you could do an over 1 there just to make your multiplying line up. So 2 times 5 times negative 12 is the top. So what is that?
Is this one from the second graph?
It's from everything that I did up above. So I was talking about angle A. So I grabbed the sine of A and the cos of A.
Okay.
I've already done the work, so I just made the replacements. These are just talking about angle B. So I did not do that because it was A. So 2 times 5 times negative 12. And 1 times 13 times 13. There's my answer. Did it come back eventually?
Kicking and screaming though.
Kicking and screaming.
Oh, come on. Really? Don't even say it.
Can't we just skip down?
Okay, I will tell you this. I think I said I'm going to do it as a bonus question for you. Yeah. I just don't want you to spend your like 3 days studying for just proofs, because I know that's what lots of you will do. So, okay, let's do this one though. Okay, what side would you start with? The left hand looks more complicated, so I'm going to do that. What do you want to suggest as a startup strategy? Make everything in what? Coses. I'm going to change everything I can find to cos stuff, because this answer is just with coses. Sine squared. Is there any replacement you can make with sine squared? 1 minus cos squared. Okay, secant. What can you replace secant with? 1 over cos. Secant is the reciprocal of cos. Okay, now I need to add that together. So I need a common denominator. So I'm going to go with cos x. So this was a 1. What would I have to do to this? Multiply it by cos. Okay, ready? I am going to factor this. What kind of factoring do you see? Which style? You have your four big styles. Which one is that one? Difference of squares.
I got it.
You got it.
I don't know.
1 plus cos x, 1 minus cos x. Now, instead of dividing by this fraction, what do you think I'm going to do? Times and flip. Now what? What?
Cancel.
Cancel. There's a cancel. Do you see it? 1 plus cos x, 1 plus cos x. So I'm left with these two things. And do you see the end? I just have to expand those out. So cos x minus cos squared x. I'm done. I did it.